Ni hao. Ni hao. Okay, now then, brother. Where was I? I spy with my eye a batusai. No, I don't know. Look, guys. I gotta do a few things here, so pardon any housekeeping, but trying to get caught up from the other day. I'm about one stream behind. So, shit. Oh, fuck. I'm getting nervous. I don't know what to do. What do I focus on first? Too many fucking apps. Okay, how about this? Let's do the intro for the uninitiated. This is not, has nothing to do with it. Although a nice lady, I don't know that it's a lady actually, offered to, well, for a fee, not for free, to do my logo. So, yeah, we're in talks, negotiating. Oh, there it is. Okay, so real quick, if you don't know what's going on here. Okay, so first thing, this YouTube channel at NicoX Narration, this is where you can go to get caught up on any of these streams. So I think Twitch now is recording them and also X, but for sure you can go here. Okay, so that is a YouTube channel. And I say that because the first roughly 46 episodes of Swift here was already done. So that was basically a comprehensive overview. So we learned a lot. I say overview, but we did actual projects and we went through basically every syntax example of the base language. So very informative, very insightful, great book, Big Nerd Ranch Guide. But yeah, that's where you can get caught up on that. Okay. I don't know that you necessarily need to. I guess it kind of depends on your learning style, but this is where we are now. So we're learning SwiftUI. It's been a few days, so I got to get reacclimated in terms of where I was. But it's been a great book and it's very visual. And so we're going to go to their site quickly because part of their deal is they don't care if content creators make content from it. They just want to shout out, which is awesome. Perfect for me, perfect for them. But other than that, no affiliation here. What else? The only other thing is you're watching me learn things in real time. I'm not learning off stream. So this is actually my raw process of learning that you're watching. Not like, oh, I'm exposed, brother. But I just mean like, don't expect Primogen type of like bouncing ideas off you. No, I'm really just also a raw learner. And I thought it'd be cool to effectively stream the whole process. Hopefully that helps some people. Seems like it's getting some attention, getting a few followers, you know what I'm saying, brother? So no, I appreciate that. But yeah, so I mean that's the idea though. So the downside to that is you have to put up with my rambling, like right now. But hey man, you can fast forward. Eventually we will get these chopped up. I'm gonna train my girl to I mean she wants to do it, not like I'm training her, you know what I mean, to be my video editor. So you know, no additional cost there. But don't wait for that. If you want to get caught up, you can always go to that NicoX Narration, right? Now, the other thing is, this is all in an effort to build an actual product. So I wrote SQL for 10 years, worked for a service company that supported an ERP, and we also did in-house custom work, blah, 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 blah. the main point is I have a lot of interesting real world concepts and problems that I took away from the food manufacturer space specifically, because that was mostly our customer base. And so a lot of the need that I identified there is based around FSMA, which is the Food Safety Modernization Act, put into play in 2008, spawned a whole sub-economy. Anyway, so we're actually building something towards that end to actually sell something, right? It's going to be a long-lived process, but we're going to get there. So I suppose that's part of me pitching the stream, as in it's going to be a full-fledged, like the whole thing, learning the language, learning the frameworks, learning the platforms, and then actually just building it and building the back end. So that's our next step after we get done with SwiftUI, which we probably, I mean, at this rate, maybe, I don't know, 2 weeks. After that, we'll do some web API design. I'm going to use GraphQL. Yeah, it's not going to be a big server. So just because I want to, because I used enough Swagger documents and REST schemas in my lifetime to not want to go back and do those of my own volition. And then we'll also do the local onboard storage. So we'll do a little SQL schema design. And then after that, we're just going to alternate between, just trying to build the thing, just really trying to build. It's called MRP Panda. That's the name of the app. And we'll also alternate whenever I, hit a wall or something like that. We'll bounce between learning C and not just learning C, but more specifically learning how to, like, we'll learn C insofar as we want to be able to understand it, what we're looking at. But more specifically, I want to look at using Swift to call into C and C++. So yeah, I want to keep it centric to Swift. So that is what I will do, and that is what you will watch. No, not really, but all right. So that's the lay of the land. Now I can. Okay, it already opened that. Yeah, we were going over some of the, just absolutely bitchin' tools that SwiftUI has. We can go back over them again at the end of the stream, but let me just something. I have way too many of these. Yeah, get out. Guess that can stay for now. Sheesh. Okay. All right. Hi-yow. And Swift Data Mastery. Oh, snap. Almost forgot. Real quick. I gotta go shout these guys out. So, yeah. Mountain Data. I think this is the link right here. Yeah. Okay, so as per the agreement, since I'm streaming their book here that I purchased, this is bigmountainstudio.com. No, really though, no affiliation. This is what we're working on right now. And one thing that I will say that is totally legitimate praise, if you watch the stream, this is completely true. That just sounds like you're lying, huh? If I just say this is completely true, as opposed to like every other time when I talk, right? But anyway, this is the only, it's actually two unique things about this course here. It's the only one that is both Swift data as opposed to core data, which core data is the predecessor for Objective-C. So we don't care about that on this stream. We're not storyboarders, we're not UIKit, we're not core data unless we just absolutely have to. So everything is Swift data, SwiftUI here, okay? And so this is the only book that I found that is both SwiftUI and Swift data centric, up to date, and has these beautiful little visual, it's great, and you're about to see it, so don't take my word for it. you will see it. But we're gonna come back. 27,000. Dang, there's a lot of them. Yeah, we'll definitely come back. Oh, they updated this, didn't they? 1,000 pages. What? Yeah. Oh, there it is right there. Animations. Anyway, my point is you should definitely go check it out. Get yourself a copy if you like. But I'm just telling you right now that on this stream, we're going to be back here covering more of this, more of these courses anyway. So they'll get plenty of shout outs, but all credit goes to them in terms of what we're about to read and the material that we're looking at. Okay. All right. Okay. Okay. So then now I can. You know what's really been chapping my ass lately? And God damn it. I'm not sure why. It just bothers me, but just watching random YouTube videos and they keep saying, I'm going to go ahead and like, you don't have to. We can see that, you know? I get it. I mean, you shouldn't be too hard on people. I'm not perfect, obviously. But then again, real easy to bitch into the mic, so I'm doing it. All right, so where do we leave off? Let's take a look at. I just want to skim through here. Let's go back actually and look at the 4 steps because that'll probably be a better overall thingamabob. There's a section called the flow or something like that. Oh, here it is. Yeah, so we're working our way through these different little concepts. So we learned about the data model, which is effectively the type system with some additional rules. And how come bollocks? Oh, there we go. Weird. Well, anyway, please turn off. Nothing wants to work right. Okay, so we're just working our way through these different things. We already went through the data model and how to build mock data. That's what we did last time, now that I think about it. What we've not done is the container portion. No, that's not true. We're here now at the view, I forgot. So we did do context. We did this. Yeah, so we learned how to, I think it's here actually. Yeah, there you go. So this, where's my zoom? Hold on one sec. So damn it, where's everything at? All right, my bad. I had to. That's the one lame thing about the Magic Trackpad. There's no way to. You just have to forget it on the wherever it's connected. If you want to hook it up to something else, you can't just do it from the device. Hard life, I know. Off. On. I was doing this on the iPad, but this should work just as well. What? So I can't. I thought you could zoom. How do you do that? Almost certain you can. On the mouse. Oh, there we go. Where does it say zooming? There it is. Use trackpad gesture. We'll show the zoom content from the other displays. What? A large view of the item under the printer, under the pointer. Oh, that's cool. I didn't know you could. Dude, well, it's not working. How about full screen? Is that even working? That works. Well, oh, is it because of this? Okay, I thought you could zoom the whole. Whatever. Okay, so now let's get down to it. Get down on it. Get down on it. Gotta feel it. Let's go back. And we are now at the stage of the query. Which is the view. So the fourth step here. But really, we're only in the second iteration of a beginning example, so we've really not dug deep into anything. So that is what I hope to do today. Get a big chunk out of it. Query, or sorry, the view. Okay, we learned about the observable process, what it's doing for you. Okay, this is a lot more familiar. Yeah, we'd gotten further than I thought. This is still the same concept, but there's a bit more detail now that we've done a few more things, but like, you know, you should be over here. At launch. It's better. Give me a red one. All right, so the model was that person model? So this was... Dude, what is happening to this fucking... where was that setting at? I didn't actually want... There we go. Yeah, I don't want that on. Ooh, that's way better. Yes, we were on the view here. And we loaded our book data through the arrays into memory last time, and then also persisted it to a text file. So that was this guy here. Wait. Yeah. Person model. Where the hell did it go? Oh, it's in our... friend model, not person model. There we go. So this brings observable and identifiable, which means when we call it, we don't have to give it the ID like we would have to in Swift proper, because the compiler does it for you, which is nice. Oh yeah, I mean, that was really the end of it. I mean, as long as you put that decorator on it, I call it a decorator, it's a macro. As long as you do that and provide the initializer, which you have to in this case. You can't do the inherent likewise or memberwise initializer. Is it member? Yeah, memberwise, where the compiler will just effectively write one for you. If you don't, it just assumes you want an initializer with every single one of your properties, which would normally work, but for SwiftUI you can't, or sorry, with models you can't do that. You do have to define it. Then through extensions, well, they showed us 3 different ways, but in our case, we started with an extension to that class that we're working with. So the idea was that we would want mock data for the friend model, so we put it in this extension. And then this particular flag here is stored in memory only. This is false by default. So if we don't want to keep piling up the mock data each time we initialize the app, we would pass true for this parameter here. And then this is coming from that toolbox of that from the container. So this is just literal insert statements for our mock data that we're working with. And that was... I think that was the gist. We didn't really get into a lot of this stuff, but we will, so let's get to it. Okay, so mock data. Now I can go back to the query. What is this showing me? Oh, just what we're going to be doing. Okay. So now we're making our button work, finally. At query. Now add the at query to get data. Then a list to display the data when it gets back. It's not very exciting. We will add data on the next page. I thought there was one. Okay, so we will add data on the next page. So what am I looking at? What is amazing about this code is what? Make it a little bigger. The type you set on query. So we're querying this array of person models. Is all you have to do. So Swift Data knows that data you want from the context. It's that simple. The model container created a model context and added it to the environment. All right, they did show us this too. Yeah. But the environment is the model context. So it's pretty, I mean, once you know what the keywords are doing, I think it's pretty, as far as configs go, configs in code, I mean, how much more straightforward can it be? You know what I mean? But I mean, you would have to be familiar with obviously the macros and then also the Swiss protocols. So, but once you know that, it's pretty intuitive. The query accesses the model context and requests person model objects. Because of built-in observation, when new models are inserted, deleted, or changed, the view is updated automatically. Yeah, so this thing, so they were effectively telling us that whenever, let's see, why isn't this? Give me my pencil, brother. Why did it quit working? That's fucking... Maybe I don't want click through. And keep it red. Fuck, man. Oh well. All right, so we looked at this. And then take note of this, right? Not entirely accurate, meaning it's not necessarily always a request response. It's more like this. So on the initial request, this pipeline gets set up. If you ever worked with like RxJS on the web side, observables is pretty much, I mean, or it seems like it's the same thing. Some form of promises or something like that. Or maybe this is more akin to a WebSocket. But you're not going over the network, obviously. But the idea is that on first connection, there is a pipeline that gets established and it stays there such that it's a two-way street. So if one value that depends on another gets updated, it's self-aware. It knows its dependencies. It'll invalidate itself and then re-render. Kind of like good old React in a very non-shitty React way, of course. Okay, I read that. So we got, wait, let's read this real quick. The actual code. First example view. Zoom in views. Oh, there it is. First example view, get rid of that. Query private var. Query private var. All right, there we go. Okay, so that is it. Query var person model. The model container created a model context and added it to the environment. Yeah, it's a lot of like chain reactions going on here, but ultimately it just goes back to that first array that we just looked at, that manually defined array. But I guess it makes sense. I mean, Swift is very two-sided. I don't know if that's the right way to say it, but you know, anywhere that you define something that uses something in the caller, you would also have some kind of corresponding keyword. So it's not like it's just you just add functionality, or you just add, you know, syntax sugar to, in this case, a class, and then on the caller you can just suddenly do more things. It's like, no, you actually got to use a specific keyword in order to finish out the defining that behavior. So one, we just looked at one, a good example of that. No, maybe it was book model. I saw a try. Or I saw an observable. We'll come across it again. But anyway, that's the idea. So now that we know what that is, and now what is this doing here? Bar body, some views, that's the opaque type. A vertical stack is wrapping it. Button add person, so that's the button we got here. Let name equal this array of 3 different dudes, I assume. Lim, what name is that? Dot random element, so that's a method call on that. So we force unwrap it. So we just hope and pray that none of these would be nil, and they're not in this case. So I take a random one of these 3, and then a person, I assign an instance of person model with name being name, which will be one of these random, or one of these 3 names here that gets passed in. And then finally, the last expression is always what's returned. So we know that model context dot insert, and then it returns the view again. So we're just passing whatever name we got into person, what is person? Oh, into the model. Okay. And then it just feeds it. And then it renders this list of people, which people is the array of person models. Person being my iterator. This is my trailing closure. So argument. And then iterator. So for every person, render the text view the person's name, which is what we get here whenever we hit the button. And then make it title font. Okay. Somewhat familiar. It's coming back. All right, no ID. Why is there no ID specified for the list view? All right, this was that. This is what the model using that macro gave us, but this right here is how we saw it in the first book previous to SwiftUI. So it's just a matter of us not having to define the ID like this when iterating over the list. All right, so wait, we already did all this stuff. Oh yeah, hop back to what we were at. How can you add mock data to Swift data without it persisting? No, we did this too. We did the if whatever true preview with mock data. Oh yeah, okay, and then he showed us how to. So we were at the, oh, okay, I was looking at query subsection. It was, wow. Okay, so let's go back here. And is this, it is, okay, that's where we left off. So this is everything that we covered on the last one. So now, officially, finally, this chapter explores all the different ways you can use the @query property wrapper in your SwiftUI views. There's also a section on how to go beyond just the property wrapper. All right. Model. For this chapter, we're going to use this model that describes parks in different regions. It is in a file called parkmodel.swift. Okay. God damn. So we have an extension on the main thread, a type property indicated by the static keyword for the preview. So this is just adhering to the protocol of type model container. And we are not persisting this data. And these are all just inserts into the context. So each time that we initialize, if we are in dev mode or debug mode, then this data would get loaded into context, and we could work with it directly in our previews, but it wouldn't persist, so it wouldn't be written to disk. Okay. All right. Oh, we haven't seen any of that. Yeah, I haven't seen that. Okay. For this chapter, we're going to use this model that describes parks in different regions. So park model. Of course, it's a class. Nothing too crazy. Bunch of properties that you might expect for such a thing. The name, the image, the region, the country, the rating, which we will assume has some logic defined somewhere. Not here, though. And then an optional date for visited. And then the initializer as required by the protocol. So we have to define it. But this is all... Actually, this is the only one. But so this equal nil is a default value. So we wouldn't necessarily have to include visited on our caller, which would make sense because it just gets calculated as self.name is name, self. Okay, yeah, then whatever we pass in. All right. And the extension, park model. Property is a view image. So this thing we learned, this UI image, for whatever reason, we haven't found out why yet. Maybe they're working on it, or maybe it's not coming at all, but this UI image is part of, what you call it? Don't let me lie to you. Let me see. Just go click on it. But it's part of the older framework. It's not, it's an Objective-C object, yeah, UI image. So for whatever reason, they're still using interop for that piece, although the vast majority of Swift UI is just Swift. And where did my... There we go. That's just a note there. And then return image if it's not nil. If it is, then return the SF symbol instead, which is in this little library, a little plus sign. So that system name that it's that it's showing right there is referring to the SF symbol. So it would show this one here, photo. If there is no image, which we've all seen that. Probably in some app somewhere. Bar view location. View location region plus, oh, so it builds that string. Okay, whatever the region is, comma, whatever the country is. Bar view rating string interpolation. We're pulling the rating from where? From over here. Yep. Wait, string, rating. Oh, that's cool. So you can just call a symbol on that. I guess if your ceiling was 10, like your rating system was defined as between 1 and 10, if the rating was 7, then you'd get a little circle filled up, 70% of the way. That's pretty cool. You could also return SwiftUI types, such as an image view, if you wanted to. Well, now I'm curious why ask Gemini real quick if I can find it. There it is. What? Wait, in Swiftlang, what is the difference between Swift and UI image? Oh, so we don't have to use it? Does that mean in a that image and UI image are interchangeable? Oh, okay. Oh, wait, misunderstood that. Okay. So no, not at all. Oh, right. So, okay, yeah. So the UI image is the raw data representation, whereas image is an implementation of SwiftUI. We don't really know what it is because it's not open source, but that's okay. Because Swift is, and we just want to use it for our benefit. So that's all good, but okay, so yeah. I'm glad I asked then because I was way off. God dang. I'm going to pee real quick. One sec. Yeah, I know I came out of the ether like that, did you? Like the Gila monster. Yeah, it's actually a pretty ghetto setup. I thought, not that I'm not grateful now. Relax, okay? But you just gotta watch it. You know, I should know better, but you gotta make sure you read the descriptions on Amazon well. Sometimes they like to add stuff to the pictures. It's not part of the product at all. So I thought I was getting a stand with some clips for the green screen, and instead they just got a big ass green sheet. So it's like hemmed up between my closet doors and the walkway. Hell yeah, brother. Okay, so we figured that part out. Okay, they're very different. I was very incorrect, but now I've seen the light. Let's get back to it. Fill in the, oh yeah, okay, so that's how we can fill in the thingamabob. Preview property with mock data. Here's the preview property for this model that returns the model container and creates the mock data. This will be used so the previews have mock data to display. This will be used so the previews have mock data to display. For example, excuse me, preview, my view, model container. Okay. I mean, we kind of know what, we've seen it work. We don't necessarily fully grasp the gravity of it, but hey. Preview, so that's just, they never gave a real answer for what that is, but it only works in Xcode, so we know that. So it's a developer tool, meaning the actual like hash preview, because we've seen it written a few different ways, but this is the current way. My view, so that's just an instance of the default setup for that class, or that view, or yeah, it is class. Then we call this modifier the container, which one, and then use it in the preview. Okay, and so that's what we would use for this thingy. Oh, well, this isn't a view, but go to view. Where are they? Where did the views go? Oh, I think he told us that. Yeah, normally they'd be in a folder, but for these, yeah, they're all inside the classes, just for ease of use. Otherwise, they would be broken out into separate files. Okay, so that, okay. Anyway, this is what I was looking for, this preview. But this is where this hash preview data would appear. So if you don't want it to persist, at least in this example, but you want to work with it, this is where we can do that. Okay, which is exactly what they showed us, yeah. Lynn, Mark, Chase, limit. All right, so if I were to pause that, or I mean, is it refresh? Oh no, that's building it. That's gonna start the simulator. No. Oh no. Okay, we can close it. Okay, there we go. That's what I wanted it to do. Just to confirm, so all that data is now gone because we restarted the preview. Pat, 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 pat. All right. So that makes sense. Makes good sense. And that is, yep, it's the only non-code things. So what are we looking at? Park model. Oh, we looked at this under an extension. All we know about main actor is that it indicates where it should run. So if you were, well, I guess it did kind of explain it, and it did make sense. So the main actor is the main thread, and so you would potentially, like if you were developing like the app we're going to build is going to be, it's going to have a lot of asynchronous code. So we will have to delineate eventually, what thread will want certain things to run on, and there would be some logic there, because if you're like, if you're going over the wire for data, waiting on a process, but want to be able to spawn a new process so that one slow web call doesn't slow up the whole thing, right? They should just, whoever can go should go, and if you're waiting on something, then get in the back of the line. That kind of a thing. So eventually we will run into it, and I just know that because, just through research even before the stream, and I briefly used Golang's channels, which, I had mixed feelings on, because everyone talks about how, or not everyone, but one of the more popular marketing angles that people take on Go is that the concurrency is so simplistic and approachable. But I'm not saying it's not difficult, but it's, actually, so I heard, I'm going to echo a very, maybe it's corny at this point. I don't know if it's mainstream yet, brother, but certain people will say, and I agree. So this isn't my saying, I wish it was, but I like it a lot, so I'm stealing it. The saying is something, God, now I forgot the whole damn thing. Basically, easy and simple aren't the same thing. That's basically it. So this is a good example of that, where I would say that Go's concurrency model with the channels is simple, but it's not easy to gain the understanding, especially because Go code just tends to be very not dry. Yeah, so it's a bit, it's a bit rough around the edges, I'll say that. Like you really would have to have a little bit of, whiteboard masturbation going on, as they say, meaning you would want to model out what you're doing. I don't think it doesn't have the mechanisms that Swift has through protocols and these different decorators that we've already seen to really, at least to me, to depend on your code readability to guide you completely, like through that design. But I think Swift does, and so even though I've bitched and moaned about how inundated I can feel sometimes learning the 4 or 5 different ways Swift can do a whole bunch of shit, I really do think, after seeing the other side and writing my fair share of JavaScript, I think it's I would prefer that. So yeah, I'd rather have the issue of too many different ways to do one thing than the other way around. Because in the real world, at least, I don't know. Yeah, that's what procedures are for too. Like, not even Swift's protocols, just normal, regular old, SOPs, like within your org or even within your own personal practice. But yeah, it's good to have options. Whoever said that first had it right. All right, sorting. By default, when you use that query to get data, it is not sorted. The order in which models are returned. Hold on. Okay. I gotta turn you down just a little. Ooh, we'll give it a rest just for a bit. I don't know how loud it comes through, but on my end, it's shredding at a rock concert. All right. Now back to sorting. By default, when you use @query to get data, the order in which models are returned is not consistent either. Using the sort parameter will allow you to return a consistent sort order of your models. Okay. So not sorted by default. And the behavior, that's interesting. So even the behavior isn't guaranteed to be consistent. Like the default sort, so it's always changing. I guess that would be, well, actually, I don't know. I have no idea. Random sorting, maybe because it's in the heap. I bet. But who knows? Okay, struct. Query unordered. Type view. In this example, no sorting is specified. This means that the data you get back is not sorted. Oh, that's way better. Oh, yeah, okay, I'm gonna do that instead. All right, so yeah, this means that the data you get back is not sorted. The order can change every time the query executes. Okay, so this is an unordered, straight up raw dogging query right there. Wow. Okay. Park row view is shown on the next page. I will be using this subview in most of the examples in this chapter. Okay. So the body, opaque type. So anything that conforms to view. Then we have our top level wrapper navigation stack. I guess that's what this is here. I wish my pen would work. Why? I don't know why it didn't work. It's very frustrating. Now it works. Okay. Well, I can't tell if click through is good or not. I don't think I want it on when switching. Actually, don't think it matters. It's just, yeah, there we go. So if I turn it off, normal mode again, back on, backspace. Okay, I guess it just didn't like the half screen. I don't know. But yeah, anyway, I guess that's what. Oh, the arrows still don't. Yeah, fuck all. Jeez, sorry. There's some booty. Now it didn't work here either. What a letdown. It was working. I was bragging about it too. Anyway, that's what this thing is a nav stack. That's all I was trying to say. Just like pointing at stuff while I do it. Navigation stack. And that wraps a bunch of list of parks. Park being the argument here in this closure. And we're just generating a bunch of instances of the park row view. And there's our nav title. It's just so easy to read. I love that. Then again, that's all we're literally doing is reading. We did type through all the code in the last, like that 800-page book, so I don't necessarily feel like we're cheating the, we got the mileage in, so more or less hoping to just fully grasp all of these concepts and then just get to work and start doing it, because then, that's going to be the best way to learn it, for real, for real. Either way, and these are just great slides, nice to look at. Yeah, just relaxing, learning. All right, park row view. Struct park row view, type view, constant name park, type park model. Okay, now we got a horizontal stack, an image view. Oh, so that's a good example then of the relationship between those two, which makes a lot more sense now. So image being the SwiftUI type, which is a type of view, but all the views we know just they render something, some view, some set of data, and it's just a loop all the way down until whatever the, like in this case, spacer being the last. Oh, I guess it's all wrapped in the H stack, but whatever. But it's all it's declarative and it's top down, so we know exactly what the behavior is going to be. So in this case, the image view is taking the UI image raw data, because UI image, the NS object we spoke about. Maybe that's why. Maybe they don't see a need to. That would make a lot more sense, actually. Yeah, so since UI image is the NS object, aka the Objective C implementation that UI Kit was using, so SwiftUI is using the same vehicle, which is an NS object in Objective C for the raw image data. But now that I understand what it's doing, yeah, I mean, it's really nothing to get up in arms about. Okay, so that's raw data, image being the view. They do not equate, but the image can render the raw data. And then also throw on the modifiers, obviously, or whatever's required there. Okay, the park model is passed into the row view to display content. Yeah, yeah. Okay, so we're starting to see the pattern here. So you have a type, a constant, that corresponds to your class, and then in your body, your wrappers for the views, and then inside of those you'll have text or image or any of the other special types, but we haven't really touched those yet. But and then beyond that, we have modifiers that can be applied to individual children views and or the stacks themselves, and they follow a hierarchy. So if you were to apply all of these modifiers, see, now I'm gun shy about using my, better fucking work. Let's see if it'll work. I guess I could go back to, I was butthurt about Epic Pen, and now Ultimate Pen has let me down too. It probably is just Apple though, because both apps are pretty solid most of the time. Yeah, I wish it wouldn't. Do I really need to? Yeah, that sucks. Very disenchanting. Mm, let me turn coat on this real quick. Da, da, da. You have been demoted. Epic Pen, you're back up. Hopefully you get an update. Nope, still doing that. Look at that. But what's interesting is we kind of learned how that might happen, which I already kind of forgot. But yeah, we went over how something like that can happen in terms of the bug and why it would only get fixed once you hover over, triggering some event to re-render. But yeah, this should work. This should actually work. So now give me these. Oh, but it's still gonna. I'll just take these two. What kind of? Yeah, slide PDF text boxes have always been a hell ton of fun. all I was trying to do is get this. There we go. So if you were to, let me get rid of that, apply these here, minus the quotes, of course, then all of these would, of course, be applied to everything inside. So to the text views, well, provided the view supported whatever the thing is. Not always the case, but for the most part, it is. So you can have these here, but then if you had the same, if you wanted one of the children to have a different frame, you could still call it individually. Well, imagine it's below it, but you get the deal. So if there's a modifier of the same name on a child, then it just follows basically what CSS does. If the child has its own setting for the thing, then it'll listen to the child. And if you don't want that behavior, you can, you have full control over that, just like in the browser with CSS. To mock out data, you need to create the model container where park model data can be temporarily stored in memory. To mock out data, you need to create the model container where park model. All right, the model containers, so effectively are a chunk of RAM that we want to use for the context, which is context being our actual data in memory while the application is running. So model container gives us the tools to read the models, generate objects, write data into memory, query the container, and then write back to disk also. Okay, but what does it tell me? To mock out data, you need to create the model container. Oh, right, okay. Or park model data. Later, you will learn another method to get mock data for your view. Yeah, there's a lot of methods. Although they all kind of, I don't know. Maybe I think we've just seen two, but they keep being re-explained in different ways, which is fine. But it's just, yeah, I think in terms of unique methods, it has just been two. And kind of just boils down to this. Yeah, okay. So preview like container, there's our model container. I didn't get an answer on the try here. Oh no, yeah, we did. That just means if it fails, panic and crash the app. Yeah, don't do anything else. Just so if you wanted that behavior, this is a way that you could just write that out. If you had a more or less a crucial step where you only wanted things to go right, otherwise just bail. Which makes sense because this is like our context. So if that doesn't work, then might be a good idea to crash. Who is hitting me up, really? Oh, it's just my X app. Relax, babe. The X app, not EX. And see? Felt my ears get hot immediately. Okay, so now to mock out data. I'm not friends with any of my exes. They actually, I'm going to assume, never mind. Let me shut up. Yeah. Okay, sort by name. Struct, query sort name, view. Okay, so before we had no, yeah, so we've only seen unordered. this was just an explanation. And now logic for the sort. Okay. You specify which model property to sort by using a key path. Key path. A key path is a way to point to a property. By default, the property is sorted alphabetically. For the key path, you have to specify the model and property. You cannot use just name for the key path. You have to specify the model and property. Okay. I mean, it makes sense. Let's see. Okay, key path is a way to point to a property. By default, sorted alphabetic. Oh, that's the default. Okay. What kind of properties can I sort? Any type that conforms to comparable can be sorted. That conforms to comparable. So as long as there's an implementation of the greater than, was that? I think that was comparable. Ooh, companion. Our handy little know-it-all app. This thing is fucking sick. Best $400 I ever spent. Let's see, it's comparable. That's a joke, by the way. It's not that expensive. I forget how much it was, but it wasn't. And it's a one-time buy. Oh, this is just SwiftUI. That's why. Silly me. Where's the? There it is. Dev docs. Oh, honestly, it should. Yeah, there it is. The comparable protocol is used for types that have an inherent order. Add comparable to your own custom types when you want to be able to compare instances using relational operators. Yeah. Most familiar use is if greater than or equal to, less than. Okay. You can call the sort. Oh, I see. Yeah. Conforming types with a comparable implement the less than operator and the equal to, the equality. That's right. And the compiler can do the rest for you, but you can define your own custom implementation, which is pretty sick. Makes it pretty easy then to